In this video, we're going to do some review of trig, just in case there are any topics that you missed or that you've forgotten from your previous courses. So first thing we're going to talk about here is the idea of radians. So let's imagine a unit circle, meaning a circle with radius 1. If we think about the circumference of a circle, it's 2 pi r, but if our radius is 1, then the circumference of that circle is 2 pi. The radian way of measuring an angle is to think about the arc length along the circumference of the circle that corresponds to our angle. So if we did a full rotation, 360 degrees, we would say that's 2 pi radians, and therefore a half rotation. So let's draw pictures as we do this. So full rotation all the way around the circle would be 2 pi radians. Half rotation, if we just went, say, from here to here, we'd say that's pi radians. So what we really want to be able to do here is convert between degrees and radians. So for example, if someone says 30 degrees and you want to put that into radians, you take your 30 degrees and you multiply by pi divided by 180 degrees. The reason it's valid to do that is because pi radians is exactly the same thing as 180 degrees. So you're effectively just multiplying by 1, not changing the value of your angle, you're just changing the way it looks. Then you can cancel 30 degrees from the top and the bottom, and you'd say that's pi over 6. You can either write pi over 6 radians, or sometimes we write rads for short, or you can just write pi over 6. And it's implied that you're talking about radians. Okay, we should be able to convert backwards as well. So if someone gives you an angle of pi over 4 radians, we wanted to put that in degrees, we're going to multiply by 180 degrees over pi. Again, it's valid to do that because 180 degrees is the same thing as pi radians. So we're really just multiplying by 1 here, not changing the value of our angle, just changing the way it looks. So you could cancel a factor of pi, cancel a factor of 4 from the top and the bottom, and that would leave you with 45 degrees. So that's the first thing we want to be able to do, is convert between degrees and radians. Second important fact for trig review is special triangles. So there are 2 special triangles to be familiar with. One is the 45, 90 degree triangle. So I'll just label the angles in here. So 2 45 degree angles plus a right angle. The side lengths are 1, 1, and root 2. If we did that same triangle in radians, well, we're just changing the way we write the angle here. Instead of calling that 45 degrees, we'd call it pi over 4. So we have 2 angles of pi over 4 plus the right angle. Side length still 1, 1, root 2. The second special triangle that we want to be comfortable with, that's the 30, 60, 90 degree triangle. So it looks more like this. So our small angle here is 30 degrees and our bigger one, 60 degrees. And the side lengths of this triangle, 1, root 3, and 2. 2 is the biggest of those numbers, that's on the hypotenuse. 1 is the smallest of the numbers. 1 is across from the smallest angle. So smallest side across from the smallest angle, middle side across from the middle angle, etc. So 1, root 3, and 2 are the side lengths there. And if we decided to draw that same triangle in radians, then we're just changing the way that we're writing down the angles. So 30 degrees is called pi over 6, 60 degrees called pi over 3, still a right angle triangle, and side length still 1, root 3, and 2. So we're going to use these special triangles in a minute to actually calculate some values of our trig functions. So third important fact when it comes to trig functions is a little something called Sohcahtoa. Basically what this means is it says sine is the opposite over the hypotenuse, cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. So this allows us to calculate things like sine of pi over 6, for example. Let's say we wanted sine of pi over 6. So we'd look at our special triangle that we got up here. And we'd say, well, according to Sohcahtoa, sine is opposite over hypotenuse. So we identify where the angle pi over 6 is in that triangle. The opposite side to that angle is 1 and the hypotenuse is 2. So that tells us sine of pi over 6 is going to be 1 over 2. So in a similar way, you could do something like, say, tan of pi over 3. Well, according to Sohcahtoa, tan is opposite over adjacent. You can identify where the angle pi over 3 is in your triangle. It's here. So relative to that angle, the opposite side is root 3 and the adjacent side is 1. So we would say root 3 over 1, or in other words, just root 3. Okay, and then let's practice, say, a cosine. Say we wanted cos of pi over 4. According to Sohcahtoa, that's going to be adjacent over hypotenuse. So we can look up at our special triangle for pi over 4. That's this triangle here. So two of the angles here are pi over 4. It doesn't matter which one you grab. Let's say we look at this angle here. And relative to that, the adjacent side is 1 and the hypotenuse is root 2. So 1 over root 2, or you could rationalize that and you could say root 2 over 2. So that's how Sohcahtoa works. Next thing we should talk about is our 3 reciprocal trig functions. Those would be cosecant x, secant x, and cotangent x. So cosecant x is 1 over sine x. Secant x is 1 over cos x. And cotangent x is 1 over tan x. So what some people do here, just to remember this, is they remember that the letters switch, the first letter switches. So if you've got cosecant, that becomes 1 over sine. If you've got secant, that becomes 1 over cos. And then cotangent x, that's a little bit easier to remember that that's going to be 1 over tan x. So for example, let's say someone asks you to figure out secant of pi over 6. So you would say to yourself, well, I know that cos is adjacent over hypotenuse, and I know that secant is the reciprocal of the cosine function. So instead of being a over h, it's going to be h over a. And then from there, we could draw our special triangle. So for pi over 6, you draw this triangle here. Pi over 6 is your small angle. Pi over 3 is your big angle there. And then side legs 1, root 3, and 2. Okay, so then relative to this angle, pi over 6, we need to go hypotenuse over adjacent. So hypotenuse being the long side, that's 2. And then adjacent being the non-hypotenuse side that's touching your angle. So that would be root 3. And then you could rationalize that. You could say 2 root 3 over 3 if you want. Fifth item on our trig review, we're going to talk about something called the cast rule. So I'm going to draw a little picture here. So we're talking about our 4 quadrants. And we're really talking about which trig functions are positive in which quadrant. So it's called the cast rule because if you read around just counterclockwise, starting in the 4th quadrant, it looks like C-A-S-T. So which trig functions are positive in which quadrant? Well, the first quadrant stands for all. The second quadrant here stands for sine. T stands for tangent. And C stands for cosine. So the thing that's sort of unwritten here is that when we say in quadrant 4 cosine is positive, what that really means, we're saying if we have an angle that's in that quadrant, cos theta will be positive, and the other two, meaning sine theta and tan theta, will be negative. So in the first quadrant, all 3 of them are positive. In the second quadrant, sine is positive, but cos and tan are negative, etc. So in the 3rd and 4th quadrants, one of them will be positive and the other 2 will be negative. So the way that that helps us is if someone says to you, okay, I want to figure out the positive or negative sign of, say, cos of 210 degrees. you would just draw a picture, figure out where 210 degrees is. So we measure our angles starting on the positive x-axis and just going around this way. So that's 180. We need to go 30 degrees further. So there's our 210 degrees. That puts us in quadrant 3, and that's the T quadrant. So that tells us that cos of 210 degrees will be a negative number. It tells us that tan of 210 degrees will be a positive number, and sine of 210 degrees will be negative. So it's just tan that's positive in that quadrant. The other two are negative there. So basically that's what the cast rule does for you. The way that we actually use the cast rule, I'll do a quick little example here, is if someone asks you to figure out, say, what is cos of 5 pi over 6? So if your angle is not in the first quadrant, the thing to do is to draw what's called a reference angle. Okay, so let's figure out where the angle 5 pi over 6 is. Well, we could say an angle of pi, that's the same thing as 180 degrees. That would be over here. So let's rephrase that pi as 6 pi over 6. And then we can say, okay, so 6 pi over 6 is all the way over there. Where would 5 pi over 6 be? Well, it would just be pi over 6 less than that. So here's our angle of 5 pi over 6, and here's our angle pi over 6. Okay, so what is a reference angle? A reference angle is always measured to the x-axis, and it's always an angle that's somewhere between 0 and 90 degrees. In this case, our reference angle is this little pi over 6 here. So it's just the distance up or down to the x-axis from our angle in question. So I'm going to erase this 6 pi over 6 here because that's just cluttering things at this point. So we drew our angle 5 pi over 6, and then we figured out our reference angle. So now what you do is you say, well, cos of 5 pi over 6 is either going to be plus or minus cos of pi over 6. So you just turn the angle into your reference angle, and then the plus or minus comes from the cast rule. So in this second quadrant, we know sine is positive, tan and cos are negative there. So that tells us that the correct sign to use is negative. And then we can think about our special triangle, and we can say cos of pi over 6 is root 3 over 2. So I'll do one more example like that just for good practice here. Let's say we wanted, say, sine of 240 degrees. So we'd say, okay, let's draw that angle 240 degrees. So that's like 180 degrees plus another 60 degrees. And then your reference angle is always measured to the x-axis. So you either go up or down to the x-axis. In this case, we're going up to the x-axis, and that amount of that angle there to the x-axis would be 60 degrees. So we say sine of 240 degrees is either plus or minus sine of 60 degrees, and the sine comes from the cast rule. Okay, so let's think about what quadrant we're in. Again, we're in the third quadrant here, so sine's going to be negative. So it's negative 60 degrees. Okay, and then we pull out our special triangle and we say, well, sine of 60 degrees is root 3 over 2. So we get negative root 3 over 2. So that is the cast rule and how reference angles work. Now you don't really need to know the graphs of the sine, cosine, and tangent functions for this course, but if you are curious to refresh your memory, you can look at the notes, and I've got the graphs drawn in there. So item 6 here, this is a really important notational point. When we write sine squared x, what that means is sine x all squared. So for example, if someone asks you to compute tan squared of pi over 6, you would say, well, whenever I see a square on a trig function like this, that's just a shorthand notation. And what that means is calculate the value of tan pi over 6 and then square that value. So we could think about our special triangles. We could figure out that tan of pi over 6 is 1 over root 3, and then we square that value to get 1/3. So this is going to be quite important as we're going to be taking derivatives of trig functions in our next section, and therefore it's really important to get this notation right. So anytime you see a square on a trig function, it just means write out your trig function like sine x, for example, and then square that value. So we're making some progress here. Item 7, we want to talk about how to write tan x and cotangent x in terms of sine and cosine. So tan x is sine x over cos x, and cotangent of x is cos x over sine x. So that's important. Occasionally there's some algebra to do with simplifying trig functions, and these are some really handy identities to know. Item 8 in our trig review, probably the most important identity when it comes to trig functions: sine squared x plus cos squared x equals 1, no matter what angle x you put in here. So let's say for any angle x. So I'm going to put a star beside that one because that one's quite important. Now, from this identity, you can actually figure out 2 other identities. So let's figure out what happens here if we decide to divide this entire identity through by sine squared x. So sine squared x divided by sine squared x would give us 1. We'd have plus cos squared x over sine squared x equals 1 over sine squared x. Okay, and then from there we can do a little rewriting, because we can think of this cos squared x over sine squared x. We can think of that as actually just the square of cos x over sine x. And on the right side here, we can think of this guy as the square of 1 over sine x. So it's 1 over sine x all squared. Okay, and that leads us to write down 1 plus, this is really cotangent x all squared. So we'll write that as cotangent squared x. And on the right side, we've really got cosecant x all squared, which we'll write as cosecant squared x. So this is a second identity that you can figure out from the first one. But what I usually do is I just remember this one, and then if there ever comes to be a situation where I feel like I need this one here, I'll just figure it out by dividing through by sine squared x. In a similar way, you could take your original identity, so this one up here, and you could have decided instead, oh, let's divide through by cos squared x. So if we do that, we'd have sine squared x over cos squared x, plus our second term would be cos squared x over cos squared x, that would be 1, equals 1 over cos squared x. Okay, and in a similar way, let's see if we can figure out how to rewrite that. So for this first term here, let's think of that as something squared. So it would actually be the square of sine x over cos x. And then on the right side, we can say this is the square of 1 over cos x. Okay, and let's see what that does for us. So that allows us to write tan x all squared, so let's call that tan squared x, plus 1 equals, well, on the right side we'd have secant x all squared, which we'll just write as secant squared x. So this is our third identity. So I would say item 8 of our trig review is just the idea that there are these 3 identities. By far the most important one is the top one, so I'm going to put a few different stars around that. If we actually put 3 stars beside that, you could say to yourself, well, there's this identity, and if I need to, I can get 2 other identities from that by dividing by sine squared x or by dividing by cos squared x. So we're almost done with our trig review. The very last item here is just to do a little bit of computation with our calculator and make sure we're comfortable with that. So we're going to do 3 short computations here. In each case, we're going to round to 2 decimal places. All right, so we go to our calculator. Calculator can do this no problem. The only issue is the calculator needs to understand whether the angle that you're putting in is in degrees or radians. So if the angle that you're putting in is in degrees, then you want your calculator to be in degree mode. Usually there's a button called DRG or something like that that you can just hit repeatedly to switch back and forth between degrees and radians. Some of the online calculators just have a little button that you click degrees to be in degrees or click radians to be in radians. Being in degree mode, we type in sine 60 and our calculator should say that's about 0.87. Now part B, let's say we wanted to calculate sine of pi over 3. Now surely this is going to come out to the same number because pi over 3 radians is exactly the same angle as 60 degrees. The only catch is that now our calculator would need to be in radian mode. So the calculator just needs to understand that you're inputting radians into this trig function and then it will give you the correct value. So then you'd type in sine of, on most calculators you'd want brackets around that. So sine bracket pi over 3 and that will give you 0.87. So now we're going to do something a little more interesting in part C. So let's say someone gives us a function, f of x, which looks like e to the x plus sine x. And they say, find f of 30 degrees. Okay, so let's think in terms of units, what would happen here. Let's look at the sine x term first. Okay, so if you put a certain number of degrees into your trig function itself is returning a number. So sine x, after you've typed it into your calculator, it's just going to be a number like 0.5. So that number has no units. Now, if we did something like, let's say we tried to type in e to the 30 degrees. Think about what your units would be. We would have really strange units. It's really weird to put a certain number of degrees into an exponent, right? So we would have a mismatch in the units. E to the x must be unitless. We definitely don't want it to be in degrees. So not in degrees, and we definitely do not want the exponent to be in degrees. So the only way to get around this is to actually say, well, let's forget about plugging 30 degrees into this function here. Let's instead convert 30 degrees to radians. So we know that 30 degrees is equal to pi over 6 radians. And we're now going to rephrase the problem as find f of pi over 6. And that will work perfectly because then e to the pi over 6 is just going to be a number. It will be unitless. That can be added to sine of pi over 6. So this is why the radian measure was invented. It's so that you don't get this unit mismatch between trig functions and other types of terms that you might have in your expression, like an x or an e to the x. If we just worked in degrees, we would have this mismatch in units, but if we work in radians, everything's unitless and our computations work very smoothly. So let's try it. So f of pi over 6 then is going to be e to the pi over 6 plus sine of pi over 6. Our calculator needs to be in radian mode. And the reason it needs to be in radian mode is because of the trig function here. Okay, and then just for the sake of the calculator, on most calculators you will need to bracket when you're putting something into an exponent or when you're putting something into a trig function. So although we don't mathematically write those brackets down when you're putting it into your calculator, you would want those brackets. So being in radian mode, typing in e to the pi over 6 plus sine of pi over 6, you should get about 2.19. And hopefully this example shows you why you can't get around working with radians. There are many examples where you're trying to add a trig function to some other type of term, and radians is the only way to do that. So that's it for our trig review, and hopefully that helped you brush up on the important trig concepts that we'll be using in this course. Thanks for watching.